Hello friends, this is Gauravjeet and welcome to my channel, The Coding Sing. And today we are talking about a pattern, like a software pattern for solving algorithm problems. So the patterns we are trying to cover today is the sliding window principle, we call it. So, so I will tell you more about the sliding window principle, but let's start with a problem so that we can first jump into the problem, understand the problem, and then we can think of this solution, this pattern, which will help us in solving this problem. So we are asked to find something on array of a given size, which is the size given here, and we have to find the average of all subarrays of size k in it. So the so if when you think about this problem, the first solution I think of is the brute force one. Brute force solution would be calculate the sum of every k element and divide the sum by k to find average, right? So it's like, okay, first calculate the average of k, in this case k equal to 5. So first calculate the average of these 5 elements, then the other 5, then the other 5, and then calculate the average and then divide the sum by k to find the average of all subarrays of size k. But the problem with this approach is the time complexity. The time complexity of this approach is O of n multiplied by k, which is O of n k, which is like star k, which is not that good. I mean, come on, we can do better than that. So the other approach I'm gonna talk about is the sliding window approach. So in this approach, what we do is we visualize each subarray as a sliding window of fixed size, and then we are reusing the sum from the previous array. So so let's take an example. So suppose in this case, this is the subarray, and then first I took 1 comma 3 comma 2 comma 6 comma minus 1, right? So suppose this is a size of k. So in this case, if we are gonna calculate the sum of this of this window of 5 elements, do you see any pattern? Like, so in our first iteration we will be doing that. In our second iteration we will be removing 1, and then we will be adding negative 1, sorry, 4. Do you see a pattern in when we will move forward? So the pattern, the easiest pattern I can think of is that what you are doing is you are subtracting one element from here, but adding an element, corresponding element here, right? As we are moving along to parse the array. So so isn't so don't you think that it will be inefficient to calculate this elements, like this middle elements, each and every time? Isn't Will there, if there is a method so that like we can. So what I was saying was that in this sliding window approach, we will be saving, when we are looping through the whole subarray, we will be saving that computation power. And since we calculate the sum, and then so the time complexity for this new algorithm would be O of n. So I would say let's go and start coding this solution. And so I will just declare and define this define this method name, and let's see. it will take one argument as k. The second argument would be array. Let's call this function with 5 comma the array, and the array would be right here. So what we have to do is first we have to look through the array and calculate the average when it reaches k elements. So suppose so we are looping through this array for, so I'm going to use two variables. One would be the window element end, and the other would be the element start. I can name it window start as in start, and then I have to calculate the sum. So for each window, the sum I'm initializing it to 0, and then I will start a loop which is window element e in 0 dot dot array dot length 2. So here what I'm doing is I'm just looping through these elements, and so I will just write a comment here, loop through array and calculate the average when it reaches k elements. So since I'm looping through it, so I will be calculating the sum as when sum plus array when e. So what, so if you understand, then what this is doing is this is just calculating like adding the numbers into a variable on each iteration while we are looping through it. And then the next step we're going to do is slide the window when it reaches k. So that's the catch, I would say. Like, this is the condition, like if condition that uh, add it. So in this case, if you will make a dry run, it will add 1 to the window sum, then 3, then 2, then 6, and when it goes to -1, then okay, it will say, oh, the elements are equal to 5, so which is window E. So when it will say like, okay, the elements are 5, okay, the elements are 5, so let's go into some condition. So let's write down that condition, which will be window E greater than equal to k minus 1. So since we are looping through it, and this would be 5 should be equal to or less than k minus 1. Okay. And what should happen at this case? I think we should store this result somewhere, and then we should calculate the results. Like, we should get this average later on, right? So what we should do is we will be, right now we are like calculating an average here, and then we'll just return it, average of the subarray. I think that would be the best thing to do. So let's start. So result when s is equal to when s divided by k. So that's the average at this point. And then when sum, okay, I think this would be when sum Win sum is equal to win sum minus win start. You know why this is? So when we reaches to this point, so over here what we are doing is we are sliding the window. So initially the elements were these 5, and now what we are going to do is we are going to remove this 1 from here and add 4. So that's what we are doing. We calculate the average, then we are removing the start, which is right now 0, which is this element. So we're going to remove this, and in the next step we are gonna we'll just slide the window as we go along, because in the next iteration we have removed it. So when the next iteration, when the next condition will come, then it will just add the next element 4. So over here this one more check we have to add, which is when s is equal to when s plus 1. So we are just iterating through it, and that's pretty much it. So, and then we can return the results, and we have to store the results, and this result is an array, and we'll see what result. Okay, let's print it out what it returns, and then we can figure out. Oops. For small for array, line number 23. Yeah. What is the problem? Index -1 too small. Okay, -1. So I think somewhere we are accessing this. Window S would be, you know what? This is wrong. Yeah. So if you will look at it, this is the array, and this is what we are returning. So the average would be this, and then average of the subarrays. So I think we got this result back. So this is what we want. We want the average of the subarray, and we got this of 5. I think we just have to calculate it. Just add it to the sum, like just loop through every element. After that, I mean, just an easy thing. So just loop through all the elements of the array and divide by k, and then you will get the answer. So I would say thank you for watching my video tonight. So this was, so let's go over the solution let's go for let's do a quick recap of the solution I talked about. So the solution was a sliding window. So we talked about that we have to loop through the array, and the window should be of fixed size, and we will move elements through this window, and then we'll keep on adding elements in the back, and we will be removing the elements from the front itself, from the window. And then as we move along, we are calculating it, and the time complexity would be O of n. So yeah, so that was about it. So I think thank you for watching my video, and have a nice day. Bye bye.